Welcome back, this is chapter 11. Up until now we have been creating classes, but if we keep going like this, creating more and more classes, our project will get somewhat unmanageable pretty quickly. We need a way to organise our classes into some sort of structure, and that's what we're going to cover in this chapter. First, we'll have a look at creating the structure by grouping our classes together into packages. We'll then see that we can import packages into our project that other developers have created, and in the same way, we could in theory give our packages to other developers for them to use in their projects. Finally, we'll understand how to make package names unique. This is going to be important if we are going to give our packages to others. This is going to be quite a short chapter, but it is an important concept, so let's begin. As we proceed through building our application, the number of classes we're creating is growing. Quite soon we could have tens or even potentially hundreds of classes. And as they sit here today, it will be quite hard to remember which class is which, or even find a class that we're looking for. So we need a way to try and organise our classes into sensible groups. Packages allow us to organise our different files of code by grouping together code that either has a similar purpose, relates to similar objects, or carries out similar types of functionality. How we group our files is up to us. It's a bit like deciding where you might want to save files on your computer. For example, a company might want to have one folder for all their invoices and another one for all their receipts. In fact, Java packages use the system of folders to store your files in exactly this way. A package name is simply a folder name. The use of packages is important to create structure within a Java program. As we'll see, this can help bring clarity over what different objects do and make programming easier, especially in larger, more complex projects. The classes we've written currently do three functionally different things. We've got a UI class that manages the user interface. We've got a book, a customer, and a book catalog class, and I'm calling those our models because they model real-world objects that we can picture. And we have a gender type enumerated type. Now we could use that elsewhere within our application, so I'm going to call that a utility item, and I'll place that in the utilities category. So we're going to split our code up into three packages. We'll have a UI package, into which we'll place our main and our UI classes, a models package to contain our book, book catalog and customer class, and a utilities package to contain our gender type class. Don't worry that a package might only have one class in it, we'll probably be adding more very soon. So let's go to our code and first create the packages. I'm just going to make this package window slightly bigger. I'll right click on my project, do new package. I'm going to call this first package UI, and it's normal to name packages with a lowercase letter, so I'll do this all in lowercase UI. I'm going to create my other two packages now. And now I need to move my classes into the relevant packages. I can do this with a drag and drop in Eclipse. So our book will go into models, book catalog goes into models, and so on. Now we might get errors like this. I'm going to ignore them for now and work out what's wrong after I've finished moving things around. And actually all my errors have disappeared. The reason the errors were occurring was because within, for example, our customer class, we referenced gender type, and yet we've moved gender type around. Once we've got everything into logical places, Eclipse was able to work out where everything is and find it again. We notice that at the top of our classes, we now have an extra line which has been inserted for us, which names the package. So we can see that our book catalog class sits within our models package, as does our book class. Once we've placed our classes into packages, by default a class can only see other classes within the same package. So class A1 can use class A2 or class A3 as long as these three classes are all in the same package, but it couldn't go and use a class from another package unless we tell Java where to find it. The way we tell Java where to find the class that isn't in the same package is by putting an extra line at the top of the code which imports the relevant class. And in our import line, we specify the package name and the class name. So at the top of our main class, you can see we are importing the book and the book catalog class, and they sit within the models package. So we have to tell Java where to find the book and the book catalog class. Eclipse put those in for us when we moved things around. If it hadn't done, and I'll take this line out and try and save my code, you'll see we instantly get errors, and if I hover over book, you can see it says book cannot be resolved to a type. Eclipse put the code in because we were moving things around, but if we were using the book here for the first time, and we type the word book, pressing Control and space at the end will give us a list of options to choose from. We can see our book class is here, but notice there's another book class elsewhere in Java, and that's not the one we want. I'll double click on book, and we'll see that Eclipse puts my import back in. But this shows an important point. You can have many classes all with the same name, but we need to tell Java which class we're using by specifying it in the import line and being explicit about which package that class sits in. I'm just going to save my code, and our errors go away. One final point on import lines. If you were typing it in yourself, you can import all classes within a particular package in one single line. And to do that, I'll remove these two lines. We would do import our package name dot asterisk or star semicolon, and that will tell Java to bring in all the classes within that package. I'll save my code and you can see we've got no errors. It doesn't make a huge amount of difference whether you choose this method or explicitly naming your classes. The actual code isn't being imported here despite the use of the word import in the declaration. It's just an instruction to the compiler to say go and look here for the classes. By default, the IDE uses the explicit version, so you'll probably see that more often than not. The IDE also has a built-in way to check and correct for any missing or unneeded references by holding down Ctrl and Shift and pressing O. If I do that now, you'll see it puts it back to the explicit references for us. When we named our packages, we used what looked to us like sensible names of models, UI, and utilities. Package names within an application have to be unique, and that's fine if your application only uses code that you've written. But that's very rarely going to be the case. We'll almost certainly use code that other people write, and of course other programmers later might want to use code that we've written. So we'll need to give packages names that are unique to our particular application. So we need to come up with a way of ensuring that every package we create has a really unique name. The standard way to do this is to start with something that looks a bit like a domain name for your company, but set in reverse. Add onto that your application name, and then your package name. So for example, we'll be using com.virtualpairprogrammers, which is our domain name in reverse, then lending library, which is our application name, and then our package names of UI or models. We use domain names rather than just our company names to try and ensure uniqueness. Only one person can own virtualpairprogrammers.com, but if, for example, my name was John Smith, there might be many people in the world all with the name John Smith, but only one of us could own johnsmith.com. If you don't own a domain name and you don't plan to publish your code, then you don't need to stick to this format. We could have just done lendinglibrary.ui and that would have been okay. If you are planning to distribute your code or publish it online in an open source format, then it's considered courtesy to get hold of a domain name so that you can follow this structure. Well, that brings to an end our chapter on packages. In this chapter, we saw that packages can and should be used to group together classes that, for example, either have a similar purpose, maybe work with similar objects, or form distinct parts of our project's functionality. We learned how to import packages that have been created by other developers, and we saw the naming structure for packages that is used by convention to ensure that all package names are unique, and that of course avoids the problem of two developers creating different packages that have the same name. Now, I should point out that for the purposes of this course, and only because we are learning, I'm not going to stick to that naming convention for packages. I'm not going to be using the full com.virtualpairprogrammers.whatever might come next structure. It's rather cumbersome to be typing it in every time, and of course, I don't expect you to be distributing the project that we are creating here. But if there is any chance that your own work might be used by someone else later on, it's a really good idea to get into the habit of using this naming structure. And of course it does now mean that you know what com.something means in front of a lot of package names that you'll come across in the future. In the next chapter, we're going to start exploring the Java library, the core functions, methods, and objects that Java provides. Together with the syntax of Java that we've been learning about so far, this will form the basis of all Java development.